Hey, what is up guys, welcome back to another brand new video, and in this video I'm going to be talking about a Newton-Raphson method using Python. Now in the previous video I showed you guys about the practical demonstration of Newton-Raphson method, but in this video I'm going to show you a full Python code for that. So yeah, without further ado, let's go ahead and start this. So let's see what we have on the screen. So as always, I'm going to be using a VS Code for that. So let's see what we have on the first line. So we have a function which returns a equation. Now the second function I named it as g, which is a derivative of the function, which takes a parameter x as the same function we have on the top. So the next function we have is a actual function which is Newton-Raphson, which takes input x naught e, and as x naught is a middle point, as I showed you guys in the practical demonstration, we actually found a middle point to calculate further values of the function and the derivative, of course. And e, we have a tolerable error, and n is the number of steps as always. In the function we have a print function which actually prints Newton-Raphson method implementation. Second one, we have a step variable which I declared as 1 flag equals to 1. Now for the condition, I actually gave condition equals to true, and just below it I actually performed a while loop here, which is a while true. So that's why I just give a condition equals to true so that I can put while equals to true. So in the while condition we have if condition, and it actually shows when the function of g equals to 0, so it's gonna print divide by 0 error, and it's gonna break the if condition here. Now the second step we have is the formula, the actual formula to find the value of x1, x2 and so on. So for that we have x naught minus f of x naught upon g of x naught. Now just below it we have a print line which actually print the whole value of that, and once we are done with the solution, what actually happens, the value of x naught becomes x1. So for that I just declared x naught equals to x1, and obviously I'm gonna just do increment in the step. So here we have step equals to step plus 1. Now for the step condition I actually declared if condition again. If step is actually greater than the number of steps, so what I'm gonna do here, I'm gonna flag equals to 0 and break the if condition. Now to switch the condition of while true, what I'm gonna do here, I'm gonna just use abs keyword, which is absolute keyword. What it actually gonna do, it's gonna switch the value of condition to false, and once the condition is equals to false, our loop is going to be break. Now below it we have if condition again. If flag is equals to 1, so it's gonna print our required root, and if not, so what I'm gonna do here, I'm gonna print non-conversion. The most important part of the code we have is the input section. So for that I'm gonna actually get input from the user in the x naught, e as I told you, which is the tolerable error. Now for the n is the maximum step. Now what I'm gonna do here, I'm gonna take x, the value of x naught, into float, so that's why I'm using a conversion here. And for the e we did the same. Now for the number of step, I'm gonna using int conversion because the number of step cannot be in the floating value, so it doesn't make sense actually. So now let's run the code and let's see what we have our required root here. So the number of guess, I'm gonna select 1. The error, I'm gonna select 2. The maximum step, I'm gonna select 6. So as you can see, we have 6 iteration here, and it is not conversion. Now let's do it again with the enter. I'm gonna enter guess here 2. Error equals to 2, and number of step 4. Now as you can see, we have required root here. We did the 3 iteration here, and required root is 2.864, so on. So yeah, that's about it. This is how Newton-Raphson method looks like in the Python code. As you can see, we just found our required root using a Python code. So what you guys think about Newton-Raphson method using Python? Let me know in the comment section down below, and I'll catch you in the next one.